Hello, I want to welcome everyone to the CPM webinar on conditioning. My name is Phil Wellhausen, and I am the Applications Manager for CPM. Brent Kramer will be the presenter today, and we'll begin the webinar momentarily. But first, I want to highlight a couple of the items that you see on your welcome screen. Due to the large number of participants viewing today's webinar, everyone will be muted. We do, however, encourage you to participate. So in the top left corner of your screen, you should see a small orange button with an arrow in it. Click on it and it opens a window. About halfway down or a third way down, you should see a gray box for questions. Click on it and you should open up a window and allow you to type a question. At the end of the presentation, then I will read the questions for Brent to answer. With that in mind, I'm going to turn it over to Brent Kramer. Brent is an applications manager based in our Crawfordsville, Indiana office. So with that, Brent.
Thanks, Phil. Hello, everyone. Again, my name is Brent Kramer, and I'm applications engineer at CPM in Crawfordsville, Indiana. And I first want to thank everyone for taking the time to join us today. I know there's some crazy things going on in the world right now, so we do appreciate the attention. And with that, today we're going to talk about conditioning and the points of importance. So some of the things we're going to talk about today would be the different sizes of conditioners that we have. Then we'll move on to proper conditioning and how sizing plays a role and how that takes effect. And how retention time plays a role in proper conditioning, how your picks are adjusted and arranged can influence your retention time. Then we'll kind of touch on conditioner fill rates and kind of what our goals usually are. Then we'll kind of change gears a little bit and talk about hot start conditioning and maybe some of the benefits that it may or may not have for you. Then we will finish up with some maintenance. So we have a wide range of different varieties and types of sizes. Our smallest conditioner being our 18-inch in diameter, 6.5 foot long, all the way up to 36 inch in diameter and 20 foot long. So there's quite a different types in between. When we size conditioners, we want to match the physical volume size with the capacity that you're running and the ingredients that you're potentially running too. For example, if you're running a low bulk density product, it may need a larger diameter conditioner to still meet the retention time needs that you may or may have. Some of the things that we can do with them is we can stack the conditioners. You can see that in the picture there on the right. That shows two of the same size conditioners stacked on top of each other. Some of the reasons we may do that is if you want to double your retention time, if you are running 60 seconds and you want 120 seconds of retention time, we can take the same size, two of the same size conditioners and put them on top of each other to achieve that. If you have space restrictions, for example, if you're running a large capacity and a longer conditioner doesn't fit in the space that you need it to, we can go to some shorter conditioners, two of them, and put them on top of each other to still achieve our goal of retention time. And then one more thing that we can do with them is if you are running a liquid or molasses addition system, then we would have a high-speed shaft conditioner on the top, followed by a low-speed shaft conditioner on the bottom, with the high speed being the conditioner that does most of the mixing, and then the low speed on the bottom being there for extra retention time. Now, I've always liked this diagram here on the right. It kind of shows all the factors that go into what makes a pellet from kind of start to finish. And if the die spec is where our pellet mill is, we can see that 80% of the factors that make up a pellet happen before it even reaches the pellet mill, with 20% of that being conditioning. So it's very important. It's something that we have to consider pretty much all the time. And some of the things that go into affecting conditioning specifically would be retention time, or how long the material is in the conditioner, then moisture, whether that be steam addition or liquid addition, the quality of that moisture, and we won't really get too detailed on this because we kind of feel that it's its own topic, and there's a lot of different opinions on sizes and orientation of steam or liquid. But we usually do say that we want, for conditioning purposes, we want 100% saturated steam. That way it's immediately available to the product to be able to mix. And then following that is temperature. We need to monitor our temperature. That way we know we're getting the proper conditioning environments. So when we size a conditioner, we want to match the shaft speed and the actual volume size of that conditioner for whatever formula and capacity that you may be running. If you are only adding steam, then we will use a low shaft speed, but those vary depending on the diameter of the conditioner in relationship to peripheral speed. And if you are using water or molasses, then we use a high-speed shaft. Now, the reason we want to use a high-speed shaft for those liquids is to give you an analogy. One that was given to me that I've always liked was when you're mixing paint or different colors of paint or paint thinner with a paint, the faster you mix it, the better it does at distributing that paint all together and evenly making it what you need it to be. And so that's kind of the same point of view, the purpose behind it. Also with steam, it's already been atomized, so it mixes easier anyway, so we don't need that extra speed to go along with it. And so overall, we've kind of seen a average retention time for animal feed increase over the years. So now our standard when sizing a new conditioner is 60 seconds of retention time, and that's with regards to steam addition only. If you're using a high shaft speed, it's going to be a little different that we might have to take into consideration. So there are kind of like three ways we like to determine retention time, each method having its own pros and cons, usually in regards to the time it takes to run that test, the complexity, and then the accuracy. So the first method here, what we call the amp load method, is probably the simplest and quickest way, but it may or may not be the most accurate just due to how we perform it. So pretend you're running full capacity or a desired capacity. You would then stop your feeder and time how long it takes for your pellet mill amps to either get back to or close to idle. And that should give you a rough approximation of your retention time that the product is in your conditioner. The second method is the whole corn or die method. And again, you'd be running at your desired capacity, where you would then add a die or whole corn at your feeder discharge, and then proceed to collect samples at the inspection door of your pellet mill and record your results with time. The results you're going to see are going to be in a bell-shaped curve because that is a conditioner is not a first in, first out vessel, meaning that you might add in your die all at once, but someone's going to kind of trickle out at the beginning, and then you'll see it kind of gradually increase, maybe plateau off, and then gradually decrease. The third method is probably the most accurate, but it's obviously going to be the most time consuming and maybe complex. And that is if you were to be running at a known capacity and then weigh the contents of your conditioner when you stop it. So let's, for example, say we are running 50 tons per hour. We then stop our feeder and conditioner. We collect the amount that is inside our conditioner, and for this example, it's 1,750 pounds. And we can then convert our capacity to pounds per second. So 50 tons per hour converts to 27.8 pounds per second. We would then take the amount we collected, our 1,750, divided by our pounds per second, 27.8, to then get 63 seconds of retention time. So why is retention time important? Well, the goal is to get moisture to the center of every particle. This will lead to uniform pellet quality and uniform moisture. So the purpose behind it is the smaller the particle size, the easier it is to condition because it's less distance for the steam to have to travel to penetrate to the center. If you have a larger particle, and the steam doesn't have enough time, then you might leave the center dry of the particle, and then you would see that effect later down the line, whether it be the pellets kind of fall apart or you don't get the proper starch gelatinization, which then you might see the results in your animal's feed conversion. And you might hear us say consistent material, and we might sound like broken records when we say that. And each situation might have its own meaning, but for this situation that I'm talking about, when I would say consistent material, I would want to see uniform micron size, or somewhat close to the same micron size throughout the entire product that you're pelleting. So if you have two significantly different size microns, then the smaller one might be better conditioned than the larger one, just for the same reason of it doesn't have enough time to penetrate to the center. Same can kind of be said if you are running a larger micron size, but it is uniform. You just might need extra time to allow that moisture to absorb. It also depends on what you're pelleting, what you're running through your conditioner. If you are running a more fibrous material, those tend to not absorb moisture as well. So that might just require extra retention time. Now I mentioned starch gelatinization. We want to use purpose of that due to we see better feed conversion. It's less energy that the animal has to use itself to break down and digest that feed. So starches usually kind of generally start to gelatinize or begin to around 150 degrees Fahrenheit or 70 degrees Celsius. That doesn't mean that is the limit. The hotter or the warmer the material is, the more the starches are going to break down even further. So there will be probably a limit or a threshold that you can get to due to our heat coming from our steam. And if you're adding more and more steam, then your moisture of your product is going to increase, and eventually you might see a wet choke or your pellet mill plug. So it kind of depends on the product specifically, but it might just come down to, again, time. As the starches break down, they tend to have their own natural binding characteristics. So as they break down, they become more sticky, resulting in maybe a better pellet quality and resulting in fewer fines that you might see. So to kind of sum up what we just talked about there before we move on, the finer the grind, or the finer the particles, the easier it is to condition due to less distance that the steam has to travel to penetrate. But we want that moisture to penetrate to the center to add that heat for our starch gelatinization. So as you see higher temperatures, that usually leads to higher gelatinization factors. But that all really just comes down to time. How long is that product in the conditioner? So ways that we can influence how our retention time is at what angle is our pick set at. The pitch of the pick is going to influence how long that product is in there. Thus, it's going to affect the ability of that particle to absorb the moisture. So when we sell a new conditioner or we send one out from the factory, our standard setting is 15 degrees convey. But all these picks are easily adjustable because we want our standard goal fill rate to be around 60%. And I will talk about that here in a little bit. But again, yes, they're easily adjustable. So how do we adjust them? Well, we have two different models, different types of picks that we have pictured here. On the left would be one from an LTC model, and on the right would be from an INF model. You can see the LTC has more of a triangular shape to it, whereas the INF is more rectangular. So I've indicated with the arrows where you would loosen the bolts to allow that adjustment. So on the left, those two bolts are kind of just like a placeholder, so that tightens that shaft down. You can loosen those and then easily with your hand just rotate it to whichever pitch that you want it to be. If you need to extend that pick closer to the shell, then you would just loosen that shaft out or screw that shaft out until you get to that point where you want it to be. But then also tighten them back down. The picture on the right, as I said, was an INF model. And that is simply just a single bolt holding that pick tight against that square shaft. And you would just loosen that as well. and then that allows you to rotate that pick. For this case, if you need to move the pick closer to the shell, you would simply move washers from one side to the other because they kind of act as spacers, so that gains you some space. Now, I mentioned conditioner fill rate, and we say our guideline for the max fill rate is around 60% full. A good visual representation of that would be, let me grab my pointer here, is if you're looking at your conditioner, 60% is usually pretty close here to the top of the shaft. The purpose of this is if you have too much material in there, then you're not giving the product enough space to mix properly with the steam, and the steam doesn't get distributed well enough. And so then you might not have the proper retention time, or as I said, steam distribution. A good visual, if you're doing it at your own facility, would be stop your conditioner at your desired capacity that you're running, open up the door, and just look to see in comparison where your feed is in comparison to the shaft. I do want to point out, so this is a good picture, where our steam is coming in at. So down here at the bottom, if you can see my pointer, this is our steam manifold, and they have those little ports in there. So this is where the steam enters the conditioner and starts to begin mixing with the feed. The point of this is we have this offset a little bit because we don't want the steam to have a chance to potentially leach out and go up the feeder inlet up here, and then get into the conditioner inlet, and then get into the feeder where it could cause clumps and some plugs. So the purpose is offset it a little bit. That way, as soon as it touches the feed, it's instantly being mixed. So since the picks are doing most of the mixing and essentially the work, they're going to be one of the items that wears the most and the soonest. So we like to tell people that we want them to check for pick wear every few months, or at least twice a year. Keep an eye on it, that way you can keep on top of it. If your pick isn't doing what it's supposed to because it's not physically there, then you're not getting your proper conditioning. We also say that we would like to see the picks about 1/4 of an inch between the shell and the pick. The purpose of that is the conditioner may or may not be perfectly round. So if there might be a flat spot, and if it's too close, you're creating a wear point. And if it's too far away, then you're not using that pick to its full potential and mixing as much feed as possible. So a quick fix would be to simply just extend the pick closer to the shell, keeping that 1/4 inch rule of thumb. So on the picture there on top right, that's a new pick, and I have kind of highlighted where you should probably, or you would see wear first, there on the corners and kind of in the front. If you are running a abrasive product, or maybe even an acidic one, then you could potentially rotate these picks every few months, like rotate them 180 degrees. That way you're using both sides of the pick to hopefully the fullest potential. Now the bottom pictures, those picks have probably been used for quite some time, and that's what we call that significant wear. There really isn't any chance that flipping these around is going to do much good, so we would recommend that these picks be replaced. I put these pictures in there just because I like the visual representation that they had of that spacer and that gap between the pick and the shell. These picks were fairly new, but they didn't have the spacing. I can't remember exactly what they were, but it wasn't 1/4 of an inch. It was significantly more than 1/4 of an inch. So it's not using its full potential and mixing as much product as possible. Then the one on the left with that little tool, I like that tool. It's a neat little thing to have. It just kind of tells you the angle that it is. You can get it at Home Depot or on the internet or something. It's pretty cheap. It's a nifty little tool to have on hand if you want to be more exact at what your picks are angled at. Okay, so we're actually going to change gears here a little bit, and we're going to switch to talk about hot start conditioning. For hot starts, the goal is to get the initial incoming material up to a certain temperature prior to it being pelleted to keep product uniformity from start to finish. So you're essentially eliminating the ramp up time where the temperature is gradually increasing to your desired running temp. So how is this done? Well, you'll need a VFD and some set of automation programming controls to be able to run this, because that VFD is going to control the shaft direction and the speed. So kind of a simple step-by-step, basic explanation of this is, if you were to run it, you're going to run in reverse for X amount of time, but at a low speed. And the whole time we're going to be monitoring the temperature as the feed and the steam is proportionally being added. So you're keeping it kind of in the front or the beginning part of that conditioner until it's up to your desired temperature. So once you get to that desired temperature, you would then change the shaft direction to forward and then increase the speed gradually. You don't want to go to full forward at full speed, because then you create a gap. So that first stuff, yes, that will be perfect for conditioning, perfect conditioned and temperature and pellet grade. But then you've created a gap where the new incoming material didn't have that same chance and opportunity to get up to temp. So you've kind of took a step back and didn't fully follow through. But again, once you get the material up to the desired temperature and you're up to full speed, then the process just continues as normal. We kind of feel these are great for customers who maybe run a lot of small batches and who want to run, or I should say, improve product quality and uniformity from start to finish. So some of the things that we can do to them, the hot starts, is we can also heat trace and insulate them. This helps reduce the condensation buildup. But I want to point out, I want to make this clear, that the conditioner, the hot start conditioner, is not a kill step, because it is not a first in, first out vessel. It will get your material up to a desired temp prior to a hygienizer, for example, and the hygienizer would be your kill step. And again, we feel hygienizers are their own topic, so I'm not going to cover them today. One of the biggest differences between a conventional and a conventional conditioner and a hot start conditioner would be the inlet picks. You might have seen a couple pictures back that when I was pointing out the steam manifold, that conditioner had flighting. That would be a conventional conditioner, whereas the hot starts are going to have what we call chevron inlet picks. And I have a little diagram here on the right that shows this. So they're kind of that triangular formation. And the point of those is, no matter which direction the shaft is rotating, whether forward or reverse, the product, those picks are going to be moving product away from the inlet, allowing more product to come in, but then slowly moving it down the conditioner tube to our first temp probe. Another thing, like I mentioned before, you're going to need a VFD to control the shaft speed and direction, as well as a set of programming controls to run that through your automation system. Now, our first temp probe that is essential for hot starts would be our flat temp probe, and that's usually located in the first third or quarter of the conditioner shell, depending on the size, but it's also on the bottom. I've indicated there in that picture. The point of it is, it's going to monitor our temperature as that product is coming in, and we want those to be flush with the shell for multiple reasons. First, if it sticks up too high, then the pick could come by and potentially break it off. If it's recessed down into the shell too much, then product could kind of build up in there and act as an insulator, and you won't get an accurate, timely reading of your temperature. And then the third thing is, if it is flush, then that same pick would come by and keep it clean, acting as kind of like a continuous brush almost. The second temperature monitoring method is with the stick probe. We like to say that these are a good secondary confirmation temp reading, because they're located in the end of the conditioner or in the discharge, sometimes maybe even in the transition between the pellet mill and conditioner. And they're still good, they still work just fine, but it might not have as quick as a response time as the flat temp probe, just because of the difference in location. The flat temp probe is going to be located sooner, so it's going to have a quicker response time and seeing your temperature changes, whereas the stick probe might have, if we're using our standard 60 seconds of retention time, you might adjust your steam, but then you won't see a response to that for at least 60 seconds. Something else that might delay that response is if, since it's a stick, that sticks out into that discharge, materials could potentially build up on top of it and again act as an insulation and not allow, again, timely, accurate readings. So it's important to keep both of those clean. The stick probe might have to be manually cleaned just because of its location, and that's just simply just wipe it off, but try not to, don't pull too hard on it, you could potentially bend it. So we're gonna kind of wrap things up here today with some minor maintenance issues or some stuff to look for. A lot of this probably is just everyday practices, but it's still good to have maybe a refresher. So as I mentioned, we want to check our pick wear and how secure the picks are. I've actually been to a location where the pick wasn't tightened down, and so as the feed was flowing through, it just kind of imagine just kind of going with the flow, and it wasn't being utilized, so it's kind of pointless, that individual pick. We also want to check for any shell wear. Again, I mentioned abrasive or acidic products will tend to wear the shell out a little sooner than a normal product would. So just keep an eye on that type of stuff. We want to keep our motors clean so they can cool properly. If you are using a belt motor, then we want to make sure the tension of those belts is taut and where they should be. There aren't very many greasing points on the conditioners, but for ones that we do have, we want to maybe give them a shot or two of grease every month or so. Pretty minor when it comes to greasing. We want to keep the bearing guards and the shaft area clean because, again, material could build up on those locations, kind of acting as a blanket, which could cause the bearings to overheat and have early failure. Again, want to keep the temp probes clean for the best timing and accuracy. And then we want to tell people not to, those doors are just held down with kind of bolts. We don't want to over tighten the doors because you could potentially egg shape the shell, creating a flat point where that pick, if it's not at that 1/4 inch spacing or clearance, could cause a wear point. So as far as equipment goes, we like to say that conditioners probably could be or are maybe the lowest cost per ton machine in many facilities. That is due to their long lifespans. We usually see a conditioner last 10 to 15 years, unless it's running a very abrasive or acidic product. And then they generally have a low maintenance cost. Those things I just mentioned before really aren't too major or out of line. One thing to also maybe consider is if you are running a certain capacity and you want to extend your retention time, which would mean you might have to go to a bigger conditioner, essentially the capital cost is the only factor that you have to take in consideration when going to a larger conditioner, because in the end, you're still running the same capacity. You just maybe gone from 30 seconds of retention time to 60 seconds. So it's something to kind of keep in mind. So kind of sum everything up here. We have many different sizes of conditioners, hopefully one to kind of fit whatever your need may be. Keep in mind that retention time could in turn affects our pellet quality, our product quality, and also that how your picks are arranged will affect your retention time. We want to keep an eye on our picks so we don't outwear them, because they can be adjusted, replaced easily, and we want to best improve our mixing. Then we talked about hot starts and how they might have their own certain benefits. And then we kind of finished up with maintenance with, you know, minor stuff, but again, it's always important. So I want to thank everybody for joining us today. It's we appreciate the time it took that you took out your busy days to partake in this. So I think with that, we are going to move on to some questions if there are any.
Yes, this is Phil again. Thanks, Brent. That was very good. Touching a little bit more on maintenance there, just before you get into the conditioner or anything in the pelleting line, please remember to lock out and tag your equipment just to be safe and have just safety as a protocol firsthand, first always. So with that, there are a few questions I want to that were brought up that I will ask, and then Brent will answer them. So the first question we have is, what are the pros and cons to preconditioning by hydrating the mash in the mixer? And in this case, we're talking about a typical soybean corn formula. So Brent.
Well, if you're adding moisture at the mixer, then if your moisture is already low, then you could build that up a little bit. But if you're adding moisture at the mixer, that potentially means that's less steam that you could add, and that would maybe potentially lower your overall heat that you gain from the steam. It could potentially affect how much of the starches are being gelatinized. We
Okay.
want to be able to gelatinize as much as possible.
Okay. The next question, what is the ideal steam pressure for conditioning?
Generally, there's a couple different places where steam is being monitored with the pressure. We usually see prior to a Mason-Nealon or the Apollo valve around 20 to 40 psi, but that's going to change a little bit depending on your atmospheric conditions, whether it's going to be winter versus summer. So it changes a little bit throughout the year, but generally it kind of falls between that 20 to 40 psi after the pressure reducing valve.
Okay. Next question, what is the main component failure due to improper maintenance and insufficient lubrication or greasing?
Well, probably first off would be if you're not greasing enough, then or at all, then your bearings are going to fail, and then you would have to replace those. It could kind of mess with the drive shaft a little bit because there's going to be a bearing on each end where it rotates. But other than that, be mainly your picks, making sure that they aren't worn out or past a certain point to keep the best mixing possible. You might see some wear in your in your shell, as I mentioned. Depending on what product you're running too, can affect those differently as well.
Okay, what is the average retention time in the poultry industry?
I would say now for the poultry industry, we usually see at least 60 seconds, but depending on formulation and maybe even if you're an integrator versus a commercial seller, that might depend on how much timing you want to be in there. But overall, I would say the average retention time is around 60 seconds.
Okay, next question, does hot start conditioning large batches in cold weather help, I guess, cold mash coming out of the bins?
Could you repeat that question? I kind
Yeah,
of I missed the last in there.
yeah, does hot start, I'm going to say hot start conditioning help condition large batches in cold weather? And it implies that the mash is cold coming out of the mash surge hopper or surge bin.
Well, you're still going to be monitoring your temperature from the beginning. So it might take it a little bit longer to get up to temperature, but I can't imagine that it would be affected that significantly. It will play it will play a role in that, but since the hot start, we're holding it in the tube until we get to our desired temperature. It just might be a matter of how much feed are you adding with the proportional amount of steam to get to that temperature before you change your direction to forward.
Okay, we'll take time for a couple more questions. What is the maximum temperature recommended for conditioning? Does not say what the product is.
Well, first of all, it will depend on the product because some are going to be more heat sensitive versus others, or heat resistant potentially. Um, I'm not really sure if there, personally, I'm not really sure if there is a limit because as your heat rises, you're going to break down more of those starches. But again, you're going to come into a point where your threshold of temperature and steam added is going to max out because your moisture is too much for your pellet mill to handle, and then you'll have a wet choke or a plug. So it might be a matter of what your beginning moisture is to be able to add enough steam or moisture to it.
Okay. How important is adding molasses to the conditioner? Is it beneficial?
I believe that just comes down to your formulation. And if you are adding it, the biggest thing to consider is your shaft speed. So in that instance, if you are adding molasses, we would use a higher shaft speed so it mixes as best as it can with the product.
Okay, another molasses question. What percent of mills in your experience inject molasses in the conditioner?
I would say mostly you see those happen more likely in a cattle feed or maybe even a ruminant animal formulation. I don't really see too much of that in poultry or swine. Um, so it kind of just depends on location and what the formulation is, to be honest.
Okay, do you recommend using a VFD on the conditioner to adjust retention time?
Well, most of the conditioners are designed to run at a certain um, hertz. So if you're using a VFD, that's obviously going to affect long term how much um, retention time you have, but you don't probably want to run for too long at a lower or faster speed beyond of what it was designed for.
Okay, and let's take one more question here. Um, it goes back to the same similar question. What is the optimum conditioner shaft speed?
So again, if you are running steam edition only, we will use a low shaft speed, but that depends on the actual size of the conditioner. Depending, because I mentioned there's the 18-inch diameter, the 24, the 30, and the 36-inch diameter. Each of those are going to have a different shaft speed due to the peripheral speed of the picks as they rotate around. We don't want to get too fast with the peripheral speed because again, the steam should already be atomized and mix easier. So it varies a little bit from about 100 to 60, depending on the size of the conditioner. That's important. Different size is going to have a different shaft speed.
Okay, I think we're ran over a little bit of time, so we're going to stop with the questions now and finish up with the webinar. Just want to thank everyone for participating and viewing. The recording will be available afterwards. You should get an email indicating that. Please feel free to reach out to Brent or myself, anybody in the CPM office with the additional questions or concerns, and we'll do our best to answer them. So again, thank you and have a great day.
Yes, thank you, everybody.